that I'll talk about, but there was an allegation saying that this algorithm deliberately had a flaw, okay, which I'll come back to. Eventually this algorithm got released. It was very widely used. It is used even today, and it is there in the syllabus of many of you, because it eventually got called as the data encryption standard, or DES. So that is how the DES algorithm was created. Now people who were having reservations about DES at this particular point, and historically nobody has been able to prove or disprove it. Even today nobody knows whether it's true. This particular allegation against DES is that apparently the US government, that is the NSA, has deliberately kept a loophole in this algorithm. What is this loophole? Without knowing the key, the US government or NSA knows how to decrypt any message. So if, let's say, we use the DES algorithm, we use some plain text, we use a key, and we encrypt our plain text to have ciphertext. The NSA at any point of time, without having access to this key, would still be in a position to decrypt this ciphertext. Now, I don't know whether it's true or untrue, but this allegation persists. And this was the allegation which drove a lot of people mad, because they said this is an algorithm which is a US government sponsored algorithm, which means that we not only should be not only trusting it, but also we should be able to criticize it, we should be able to find flaws which the government doesn't allow. And hence a new generation of hackers was born, which is where I'll come to now. Now when we say hackers are sometimes born, sometimes they are made, a classic example here is where the hackers were made because of the creation of the DES algorithm. Now what happened was, along with the creation of the DES algorithm, those were the times of the Vietnam War and a lot of uncertainties that were happening in the US. There was tremendous criticism within the country that the US is an imperial nation, right, which means that it wants to rule the entire world with its might. And as a result, people said DES is another example by which it now wants to even control information on the internet. There was no internet, but on the computers and subsequently on all the networks. Which is why a lot of people started saying we should not be using DES. The question was, if we don't want to use DES, what should we use? Because there has to be some cryptography on the internet. And this caused some people who were technically minded, who were interested in cryptography or interested in mathematics, to say we would create our own algorithms. And then there were two such people who eventually turned around the entire history of cryptography. It's very difficult to say whether those can be called as hackers, because the term hacker itself is very subjective. People interpret it in a different way. But these two people and the student community would eventually get to know their names. The first of them is a person by the name of Wilfred Diffie, who was born in 1942. And the second person, Martin Hellman, who was born in 1943. Okay, so there's just a year's difference between their ages. So these two people decided to come together, and their backgrounds, interestingly, were also very different. Diffie is a person who obviously is a genius, who still works. Diffie works for Google now, if I'm not wrong. So Diffie is a person who did not, for whatever reasons, okay, and I'm saying did not, I'm not saying could not. So he did not or he would not read until the age of 10 for whatever reasons. So he said, I don't want to read. Now thankfully, Diffie's parents were very understanding. Diffie's parents were unlike most of the parents that we see today, right, where children are forced to not only learn whatever they are supposed to know, but they are also forced to learn much beyond their current age. Right? So there are a lot of children in the 6th standard and 7th standard preparing for IIT, right? While they are in the 6th standard. So there is the state of affairs. Now Diffie's parents thankfully were not such people, but they were very supportive. So they would read out text for him. So they would read out books for him. And they would say, you go on, you clear exams and so on, just based on this reading. And he would happily do that. He successfully managed to do that. Apparently now, after the age of 10, something changed, something clicked in his mind. And he said, I now want to start reading. And when he decided to start reading, he finished his school's library. And remember, we are talking about a school library in the US. right, which is several maybe several times larger than our usual school library here. So Diffie finished his school library in a matter of a month. Okay, that is what his biography says. So obviously it means that he's a very genius kind of person, and he decides his own course of life. A perfect recipe for someone to eventually become a hacker. And Diffie was a person who had a lot of background in what happened subsequently. The other person is Martin Hellman, who had a very I would say straightforward background. So he graduated, post-graduated, he did his doctorate at MIT, and then he subsequently started teaching at MIT. Now, both of these people had a lot of interest in cryptography since the childhood, and later on they also came to know about the mutual interest. So Diffie came to know that Hellman had his interest and vice versa. There was one occasion on which Hellman was about to deliver a lecture on cryptography. And when Diffie heard that there was going to be such a lecture, he decided to attend it. And he actually drove down several hundred miles to attend this lecture. He met with Hellman. Apparently they had decided before meeting that they would meet for about half an hour, discuss about cryptography, and then they would go back to their own work. So this was something like 3 in the afternoon, local US time, when they met. And when they met, they did not realize how long they had spoken to each other for, only to realize that it was midnight. So they had actually spoken, they had just gone and talking with each other for about 8-9 hours. Okay, without even thinking about what the time was, whether they had any other commitment and so on. So the point being that both of them had tremendous interest in a common subject. They realized that they could form a partnership and create something about the DES algorithm. Now, why were they so much opposed to the DES algorithm? Because of the two reasons. First was they were against the Vietnam War, like a lot of other people, and secondly they were also thinking that the DES algorithm was one more step taken by the US to get into people's privacy, so they wanted to break it. As a result, then they started working on one common algorithm which would be perhaps used by anyone without having to rely on a central government authority like the NSA. And they spent the next couple of years trying to think about it. Hellman at that particular point of time, as I mentioned, was at MIT, he was a professor. Diffie did not have a job. So Diffie was invited at MIT, Diffie was given a scholarship, and that's how they progressed. After a couple of years, they came out with something which has changed the entire history of cryptography, which has actually made the internet the way it is today. We would not be in a position to use the internet without what Diffie and Hellman have actually achieved. And the background to this is that they came out with a solution to a problem which cryptographers were not able to come out with for several centuries, maybe over a few decades. In case you don't know, the biggest problem in information security or cryptography is the problem of what we call as the key exchange or the problem of key agreement, which is that if, let's say, there are two people who maybe can't see each other, they can't meet each other, but they want to share a secret. So there is a person A, let's say, sitting in this room, there is another person B sitting maybe in another room within Pune or maybe even outside of the country, let's say in the US. Now A wants to share a secret with B. Obviously someone who wants to do this has to use cryptography. But the trouble is, what is the key that you should use in order to secure your message? You can use an algorithm. For cryptography you require two things. One is the algorithm and second is the key. So you can decide on any algorithm that you want, but how would you exchange this key with the other person is the problem that you can't solve, because unless B also has the same key, B will not be able to decrypt the message. And this problem has not been resolved in the entire history of cryptography satisfactorily. And this is where Diffie and Hellman had said that while we want to find an answer to DES, we also want to resolve this problem. And this is where they famously came out with two schemes which are extremely important, which have completely changed the way we look at computers, the way we look at internet from information security point of view. The first thing that they came out with is an algorithm which is called as the Diffie-Hellman Key Agreement Protocol, or Diffie-Hellman Key Exchange Protocol, using which two people A and B can randomly exchange certain values and independently derive the same key on both sides. So they don't have to exchange a key. So that problem is solved. Unfortunately, this also has